Okay, a baseball glove is falling in air, a distance of 8.5 meters. It starts from rest, and then it returns to the ground at negative 9.5 meters per second. It's our job to find out how much thermal energy is lost due to friction. Well, we start off again, and we have to determine the energies before it moves and after it moves. So we assume it starts from rest, and the figure says so. So no motion, so no kinetic energy. Let's place our origin on the ground. Therefore, initially we are above the origin, so we have gravitational potential energy. There are no springs attached, so no elastic potential energy, and no one pushing, pulling, or tugging on it. So there's no work done, so we have all gravitational potential energy. On the right side of the equation, we are returning to the ground. It says we have a velocity, so there's definitely some kinetic energy there. Okay, and since we're returning to the origin, there is no gravitational potential energy. No springs attached, so there's no elastic potential energy. Okay, and our job is to find the amount of thermal energy, so we assume that the air resistance does come into play, so we'll say plus thermal energy there. Okay, now our job is to place numbers into the equation again. We do have a mass of 0.55, so 0.55 times 9.8 times the beginning height of 8.5 meters. That gives us our gravitational potential energy equals 1/2 0.55 times negative 9.50 meters per second squared. So we'll just square that. Okay, well that's actually negative 9.5 meters per second, and we're going to square that. And then plus thermal energy. And thermal energy is our unknown, treat that as a variable like x. And then we're solving for x in this equation, and we get an answer of 21 joules. So that's how much thermal energy is lost while this glove is returning to the ground.